Revit is a three-dimensional design and two-dimensional documentation application. Revit was created for Building Information Modeling, or BIM. BIM is an integrated workflow built on coordinated, reliable information about a project from design through construction and into operation. With a desire for more efficient design and construction, along with energy-efficient buildings, BIM is becoming more and more important. The Revit platform is designed for the purpose of building information modeling. From initial concept to construction documents, Revit uses tools specifically designed for your discipline using one of the three vertical applications of Revit: Revit Architecture, Revit MEP, and Revit Structure. This course focuses on Revit MEP, but there are many similarities in the core functionality of the tools. Modeling building geometry in Revit is not like modeling with a visualization tool like 3ds Max or using solid modeling in AutoCAD. In Revit, you represent form using objects that behave like their real-world counterparts: doors, walls, furniture, ductwork, equipment, columns, and beams. Bidirectional associativity refers to the ability to make changes in one place and have that propagate to all views. You can work within any view, including schedules, and the data and graphics of your building model will always be in sync. Revit accomplishes this by creating a new paradigm in the way information and change is managed. Everything relating to the model is stored in a single file, a database that holds graphic display and construction specifications together. By eliminating the duplication of information across separate files, information always remains consistent and current. An item is never going to be displayed correctly in a floor plan and incorrectly in elevation or section, or on a schedule. It is either always right everywhere or it's wrong everywhere, significantly increasing the odds that you will find and correct potential errors and omissions. Revit is a parametric modeler, driving geometric change from information supplied by the designer. For instance, a single door style can have many sizes, materials, and even types of hardware. Revit creates these differences with user-entered parameters, making a single graphic element flexible and consistent in different situations. Not all building modeling must be 3D. For in the case of BIM, the real power is not in the graphics, but in the information behind the pretty pictures. Highly complex items, such as medical equipment, may not provide high value for the amount of labor required to accurately model and represent in Revit. If creating a high-quality, photorealistic rendering were the only goal, then perhaps it would be appropriate to model everything to a high degree. Architecture and engineering projects don't usually have Hollywood-style budgets, so you need to find the right balance of efficiency and usefulness for each project model. In many cases, items only need to be loosely represented, and can even be depicted in 2D when they just need to be specified by the designer and quantified in the model. Keep this in mind when planning how to use Revit on your projects. Another concept to grasp with Revit is that there is only one database or file, and all the design is done in that file. Recall that there are different vertical versions of Revit, but each version produces the same file type. These Revit files can be linked into other Revit files. Therefore, each discipline can link the others into their model. By doing this, the project is accomplishing the goal of BIM, since everything that will make up the building is in a coordinated model. The main idea is to build the building virtually before it's built.